Hello and welcome. In this video, we've got another simultaneous type series and sequences in series question, really. So we are. Let's read the question together. So an arithmetic series has a common difference of five. Okay, so that's key. So common difference is five here. The sum of the first n terms sum of the first n terms is 160. And again, the sum of the first two n terms is 725. Now, you have to determine the value of n. This is about 6-7 marks, this question. Okay, so each thing gives you an equation. Obviously, that's not going to give you much of an equation other than the fact that d is equal to 5, right? So that one is not going to be like that's just some knowledge you must have, that the fact that d is 5. But this does give you an equation which you can solve for unknown things. So sum of the first n terms, so which we know, sum of the first n terms, sorry, sum of the first n terms is written like this. All right, this is what we know: 2a plus n minus 1 times d. So sum of the first n terms is equal to 160. So if so as n is equal to 160, so that means you just have to put 160 there, and I don't really know what n is yet. I also don't really know what a is because they don't say anything about the first term. I, um, however, know that d is 5. I know that, so I can put that in. And this might be a little bit more beneficial if I simplify it. And maybe this division by 2 is not the nicest thing, so I can just go and multiply the 2 on the other side, giving me 320 is equal to I might as well multiply the n. Remember, by now the 2 is gone. This is just n because I multiply the 2 over. So n times this and times everything over there as well. So that's going to be 2an plus this is 5 times n, but also times that other n. So it's basically 5n squared minus 5n, because that's 5 times -1, and then again that n is also multiplying in, so that would be that would be the equation I have. Okay, so that's one equation, which I got this equation from that green highlighted thing, really. um, Now, the purple does give me a little bit more information as well. So I need, because I wouldn't necessarily find n with this. I wouldn't. I would have if I knew the first term, but I don't. So this a would make it hard for me to do it. So I won't be able to do it unless if they had asked me to find it in terms of a. That way I would do it, but I don't think I can in this stage. So luckily, I have another piece of information which I could use to create another equation, and that is the sum of the first two earned terms. And that's okay. So sum of the first two earned terms simply just means that it's the same as it's the same as this thing, because this means sum of the first n terms, but now I have to go two n terms. So that means it's the same as that, just I have to replace the n with 2n, 2n and 2n. And that would mean sum of the first two n terms. So I'll write this properly. I just kind of want to show it over there. So this shouldn't be confusing because it's the sum of the first two n terms. I follow kind of the same blueprint. So it's S2n is equal to, instead of n, I say 2n over 2. This is still 2a plus, instead of n minus 1, I say 2n minus 1 times d. And I can still solve this. So you should never be confused by changes, because they could easily say the sum of the first x terms. Then you just then that would mean the entire thing would be sx, x over 2. That would be x minus 1 over there. So it shouldn't be too confusing. You just kind of follow the same thing again. Obviously, they said the sum of the first two n terms is equal to 725. That means I'm going to say 725 is equal to, ooh, luckily, look at that, these twos are gone, so I'm just left with n there. Um, and so I'll say n, and the bracket is still 2a plus 2n minus 1, and I know that d is 5. And now I can simplify this a little bit further, and I've got 2an uh, plus 2n times 5 times n, that's 10n squared minus 5n. And I've got the two equations now. So I've got that as my first equation, these as my second equation. I can't help but notice that these have the same 2an. They also have the same negative 5n. This to me, I think, is one of those things you just like to have because things are going to cancel out if you can do some sort of elimination here. If you can just go and say equation 2 minus equation 1, which you're always allowed to do this, right? There's nothing wrong with this. You can always do this as long as you follow the order. So you're going to go 725 divided by 3, not divided, sorry, 725 minus 320, which would be 405. And then this is why you're doing this, because you can go 2an minus 2an, and those are gone. This immediately eliminates a, and a is problematic because you're not even looking for it, and you don't even know it. So having that ability to minus it out is actually really cool. That means you can solve this really simply. So now you go 10n squared minus 5n squared. That's just 5n squared. And negative 5n minus negative 5n, that's 0 again, so that makes it a lot more simpler. And we can now divide by 5 on both sides, giving us 20, sorry, not, so you divide both sides by, why am I messing this up? That's going to give you 81, yeah, 81, and that's equal to n squared. And then obviously you can square root. You don't have to do plus or minus, which typically that's what you would have done if you're square rooting. But because n is always positive, you can just do the positive version. So um, n is actually 9 for this question. Okay, so that's all you do for this question, and I hope you learned something from this. Thank you very much for watching, and I'll see you in the next one.